Hello, welcome back to Cracking the Cryptic and a puzzle by Staxis. Don't worry, you're not seeing dots before your eyes. This is what the puzzle looks like. And if I'm brutally honest, it's got a terrifying rule set. So we'll have a look at that in a minute. I don't know if I'm ever going to get through this puzzle. It looks absolutely crazy to me. I mean, there's so little info. Anyway, enough suspense about that. Don't be in suspense about our Patreon monthly competition. The reward for this month is Spider-Man Sudoku, 8 enemies to battle. Some of them proving very difficult, especially Venom, I think. But people have worked through them. There's some wonderful people on Discord, on the Patreon chat channel, who will give you definite guidance through some of the trickier parts of the trickier puzzles if you're interested. And some people have just said, yeah, it wasn't too bad. Got through it all logical, lovely, which is great. So do check it out. There are other things on Patreon, of course, gridogram and connections, videos and crosswords occasionally. So loads of content there and an absolute pleasure to bring it to you. As it is with our apps, they feature line and domino Sudoku, but also the worms by Blobs amongst others, and great fun they are too. Check out the site either for Android or for iPhone or for Steam. The links are listed under the video, along with how to contact us, where Discord is, that kind of thing. We'd love it if you engage with the channel. There's some merch there as well, so you could get yourself some Rat Run merch or a little Cracking the Cryptic mug, perhaps. Anyway, do check it all out. But the first link under the video is to Staxis's puzzle, Assembly Required. And I am going to go through the rules now, which frankly boggle the mind. So, first of all, normal Sudoku rules apply. So 1 to 9 will go in every row, column and 3 by 3 box. Then we learn that arrows, region sum lines, Renban lines, Dutch whisper lines and parity lines are not given and must be placed. White circles must be on an arrow, either as their circle or part of the line. Blue circles are on region sum lines, pink circles are on Renban lines, orange circles are on Dutch whisper lines, and red circles are on parity lines. Now, all arrows must have one or more, all arrow circles must have one or more attached lines. All region sum lines must visit multiple regions, otherwise they'd be a bit meaningless. And all Renban lines, Dutch whisper lines and parity lines are at least 2 cells long. So those are the rules that make these not meaningless, sort of loose circles in arrows or 1 cell lines. You know, the lines make sense. Now, the rules for each line: on an arrow, the digits on the arrow add up to the number in the attached circle. The box borders divide region sum lines into regions with an equal sum. Consecutive digits along a Dutch whisper line have a difference of at least 4. Neighbouring digits on a parity line have different parity. One is odd and one is even. And on a Renban line, there's a sequence, there's a set of consecutive digits in any order. Now, there are also there are some extra rules which are going to be vital because we've been told almost nothing so far. There are exactly 9 cells on the arrows, and they contain the numbers 1 to 9. And the same is true for the region sum lines, the Renbans, the Dutch whispers, and the parity lines. So each of the 5 types contains all the digits from 1 to 9, once each. No cells in the puzzle are a member of more than one line or arrow, one type only for each cell. But lines and arrows can cross diagonally. I mean, it's weird. This is weird because there's just nothing given here. I'm going to attempt this puzzle, see if we can work out how to solve the puzzle. No idea. Let's get cracking. This could be a long video if successful. I mean, there are these red dots. These are scattered around. Yeah, okay, I've got a conclusion. We were told that for the parity lines, actually there's 5 orange dots too. I'll look at those in a moment as well, although they're closer. But the red dots are quite scattered. Every parity line is at least 2 cells long. We can't have 5 different parity lines because that would require 10 cells and there are only 9 digits in each set. So we've got to connect up at least 2 dots here. And we've got to connect them up such that either 2 dots connect in 3 cells or 3 dots connect in 5 cells or 5 in 7 cells. I think we have to connect up these 2 dots. And I was going to say through that cell, but it could of course be a diagonal line going through that cell. I'm going to colour these red just to help my understanding of the puzzle. I'm going to colour these ones orange, these ones blue. I mean, this is just nothing. I guess grey for the arrows and pink for the Renbans. Oh, right. I mean, this helps me see that there's a Renban clearly jutting out of that cell into that one. Okay, I'll get to the Renbans in a moment. Sorry, the final conclusion with these red lines is those 3 digits are part of 2 cell lines. And then these are part of a 3 cell line, and that's going to use up all the digits 1 to 9. The 3 cell line, okay, here's a conclusion. Each of these 2 cell lines is 1 odd and 1 even digit. This 3 cell line is going to have 2 odd digits and an even one in between them. There, I've done a pencil mark. Now, this pink line must jut into that cell because it's not allowed to share a cell with another line. The Renbans, these are similar to the reds. There are 4 of them this time. And I was going to say they don't join up, but actually I'm not sure. This one could join up and be a 5 cell line, and that a 2, and that a 2. Otherwise, oh, sorry, do excuse me. I am raging now. That doorbell wasn't even for me. It was a mistake. Right. Pinks, I don't know. I don't know with these Renbans. There's not just the possibility of a 5, could be either cell actually, and 2 2s. There's a 3 and 3 2s. Yeah, they're no use. Let's look at orange. Orange is Dutch Whisper. Each line is at least 2 cells long. Again, there are 5 dots. We must connect at least 2 of them together. And only with 1 cell in between. So that's that one connecting to either this or this. But then they could connect on and be a 5 cell line with a 2 and a 2. Oh, bother. These are too close together. The red actually told us, I mean, nothing has told us anything. Oh, the blue lines have to go into another box, don't they? So that one must go at least that far. Now, there is something with blue lines. These are not going to be... Right, yeah, okay. I'm a bit puzzled by the blue lines. This might be the key. This might be the key. Right. Why are there not 3 sets of 3 cell blue lines? I've got an answer to that. If there were 3 blue lines... Ah, yeah, this is very... I'm sorry, I'm getting overexcited. This is very interesting, and I am puzzled. If there were 3 cell blue lines, let me just imagine some up like this. that would look like it could work in theory. You could have a digit there that was the sum of those two, a digit there that was the sum of those two, a digit there that was the sum of those two. Perfectly normal. It won't work because of parity. Because the numbers 1 to 9, this is a secret we sometimes share with you, they add up to 45, which is an odd number. But every individual blue line that goes into 2 boxes exactly is even, because x in one box equals x in the other box. So the total of the line is 2x. Let me just remove those. Right. So if we had any number of lines that go into exactly 2 boxes each, they would have an even total, not 45, and that's not allowed. Now, there's a corollary. No, there's another fact that we cannot have a 2-cell blue line in this puzzle at all, because that would be 1 cell in one box, 1 cell in another box, and they would be the same digit. That's not allowed by the rules. We have to have different digits on the blue lines. We can't have, I was thinking at one point, maybe we have a 3-cell line that goes in 3 boxes. That's just as illegal. And I don't know what we actually do. Are we going to join up these two somehow? And what good does that do? That does do some good. I think we might have to join up these 2 dots. I don't think this one can reach any of the others, because it would need to be no more than 6 cells long. 4, 5. See, that would be 7 cells long. Let's leave aside whether it could be fulfilled, but you can't then have a 2-cell line over here. So this can't join up. I think my feeling strongly is that we can't have 3 separate pieces, because you can't have all of them be 2 boxes, and you can't have any of them be 3 boxes. Right, that is correct. Every blue line that exists in the puzzle must be a minimum of 3 cells. 2 is impossible. We've ruled that out. If we had 3 separate lines that we can't do by 3, 3, 3, one of them would be more than 3 and one of them would be less than 3, and we've ruled that out. So we have 2 blue lines in the puzzle. One is down here, and this one can't reach. These 2 have to connect. And that's really weird. And we're not finished with the parity argument there either. Because this line is going to be even, because it's going to go into 2 boxes. Hang on. Maybe this line extends into a 3rd box, which is difficult, but it isn't impossible. And then that would be divisible by 3 and could be odd. And this one at 4 cells would be divisible by 2 and would have to be even. So my point is that there are 2 blue lines in this puzzle. One of them has an odd total, and that odd total has to allow it to go into an odd number of boxes, which has to be more than 1, can't possibly be 5. That line would be too long and crazy. And there, even with 6 digits to connect these, we can't get into 5 boxes. Mind you, we nearly can. Oh, hang on. No, we can't quite. It's blooming close. I mean, that is 7 digits. Okay, well, I was very glibly ruling out that one line could achieve 5 boxes. I mean, it's complete nonsense, because at least 2 of the pieces of that would be 1 cell long and would have to be the same digit. That is nonsense. So this line is going into 2 or maybe 3 boxes if it goes there. Actually, it could go back into that one. It could be 4 cells long. This line is obviously in at least 2 boxes. Okay, I don't know. One of those lines has to be going into an odd number of boxes, which is 3, and each segment sum within each of those boxes is an odd total. And that's quite interesting, but I don't know how to draw the lines. I mean, it strikes me as likely that this one goes into that box. Like, it might be a line like that, but actually, to get this line into 3 boxes, it would have to be at least 5 cells long. Yeah, but no, I don't know. I mean, what I've said is right. One of the lines goes into 3 boxes, and the other one, yeah, I don't know. One of them can have an even total, and the other one doesn't have to. There are 2 blue. I don't know. There are 2 blue lines. One of them has an odd total. That one must go into 3 boxes. Maybe I can't say anything beyond that, but even that, even knowing that there's 2 blue lines and I'm going to have to connect these 2 digits, is quite interesting. Because isn't that going to break up the grey lines? We can always, of course, do parity swaps. Do diagonal crossing. So I haven't even enabled the pen tool yet. It's going to be necessary. We could theoretically have a blue line there and a grey line there. Not well. Oh, I've lost complete control of the pen tool. A grey line there. Right. So there is no crossing embargo. What about the arrows? They're the ones I haven't thought about, actually. And I was thinking, well, there's the same problem in a way. The arrows, they're very like blue lines in that there's a circle which is separate from an arrow. And if you have a one arrow, if you have a one arrow connected to one circle, the total of that is even. So there must be a circle that has at least 2 arrows from it in this puzzle. That's required so that you can have an odd total from one of the arrows. Now, what's up with those arrows? They are going to be so the minimal case of an arrow that I was thinking of was 5. Okay, the arrow, hang on. The arrow with a circle and 2, the arrow that adds up in total, the arrow unit that adds up in total to an odd number, and there must be one because of this 45 total again, at least one, must have an odd number in its circle and 2 tails that can't use the same digit again. So we're talking about a minimum of 5 in the circle with 1 4 and 2 3 on the arrows. But that's going to leave 6, 7, 8 and 9. You can't make up arrows from those. It just doesn't work. There's no way. There's no equivalencies. So that's not what happens. What about 7 in a circle with 2 tails? Well, you're going to be left with 9, 8 and 2 digits, or maybe 2 digits that add up to 7. 9, 8, 1 is another successful arrow, but it's just not possible. So 9 is in a circle on an arrow, and if that arrow had 2 tails, so that we could have 3 multiply 3 by 9 for the total of that arrow unit, we would be left with 2 pairs of digits that add up to 9, because all the digits that aren't 9 separate up into pairs that sum to 9. 1, 8, 2, 7, 3, 6 and 4, 5. And 2 of those could be on the arrow unit, the odd one. Ah, I know what it's going to be. It's going to be 1 2-cell unit and 1 3-cell unit, like 2, 3, 4 and 1, 8. No, it's not, though. Oh my goodness, I'm going to have to do some aide-memoiring. Right. 9 is in a circle on an arrow. Its tails can be any of the 2-cell units, 1, 8, 2, 7, 3, 6, 4, 5, or the 3-cell units, 1, 2, 6, 1, 3, 5, or 2, 3, 4. Now, the combinations of these, if you had 9 with 2, 3, 4, it would have to be with a 1, 8 on the other tail. But then you'd have 7, 6, 5 left over, and you can't make up a separate arrow from those. Eliminated. 9 with 1, 3, 5 would leave the other tail being 2, 7. You'd have 4, 6, 8 left over. You can't make up a separate circle with those. 9 with 1, 2, 6 would have 4, 5. That was the one I was thinking could work. But you'd be left with 8, 7, 3. That doesn't make up an arrow. So none of the 3-cell units occur. 9 with 2 of these, any 2 of these, is going to leave the other 2 behind. But that's a set of digits adding up to 18. What are you going to put in the circle? You can't put 9 in the circle again to make the other 3 digits add up to it. You can't have 2 separate arrows because one of them's going to be 1 cell long. I think the only way to do this is the extreme way, well, let's put it back. The extreme way of a 9, and all of these are connected to it. They're all 4 tails from the same circle. Well, we've proved everything else is impossible. That is what is happening. And that means, and this is astonishing, all the grey cells are connected together. Further, it means that all of the grey cells in this puzzle, and we still have to find 6 of them, are within 2 steps of the 9. And I think the 9 must therefore be, I was going to say in one of those 2 cells, but specifically here. You can't put it here, or you couldn't connect to this one without going through orange. So that's the 9 in arrows. That's the circle. And then every other arrow, or every cell on an arrow connects to that. That's one of the connections. This is either a 1, 8, a 2, 7, a 3, 6, or a 4, 5 pair. This is connected. This is connected via that cell, actually. And now what's happening to Mr. Blue that has to connect up? It's got to come through here. This is exactly the path I depicted. So how, oh, hang on, no. Grey could connect up. No, it can't. Blue cannot. Oh, I don't know. I was going to say, blue can't be in this cell, or we'd have 2 1-cell pieces in. Yeah, that's true. This is now a 1-cell piece in box 5. The rest of this blue line cannot be 1-cell pieces, or we'd clone a digit. We'd have a digit repeat it. We'd repeat a digit, not clone it. We'd repeat it. This is a 1-cell piece. It can't connect to anything else in this box. So every other piece of this blue line is a 2-cell piece or more. And we have to hit 2 cells. We can't come through this cell because that would be another 1-cell piece. That's not blue. If we knew that blue could only be 5 cells long, we're definitely coming through here and here. Yes, we do know. Oh no, I was going to say we do know that this blue line goes through exactly 3 boxes. Well, we do know now that it goes through at least 3 boxes and is at least 5 cells long. This one, therefore, can't go into 3 boxes anymore because it would have 2 1-cell pieces that would be repeat digits. So this one goes into 2 boxes, this one goes into 3 boxes. But it could have a 3-cell line in one of the boxes. It's clearly got a 1-cell segment. It could have 2 or 3 here. And 2 or 3, but these are the only 3 boxes it goes in. It can't go into a 4th one. So it must join through that link. That's extraordinary. That's an extraordinary finding. So these 5 cells are on, right, I mean the 8 blue cells I've coloured are all blue. That's all correct. There is 1 more blue cell to find. Okay. If it was a 3 and a 2-cell piece here, this digit would have to be 8. Oh, by the way, grey has just connected up here, hasn't it? There we go. There's my 1 grey line. There's another one. There's another one. Oh, where's the 4th one? That's there now. That's the only place that we can emanate from this octopus 9. Oh my goodness. Okay, well we found all of that type of cell. We found all the greys. Orange, by the way, must now continue down to there. Oh, that orange is now not going to connect up. Weren't we only allowed to connect up? No, we had to connect up 1 orange via 1 cell. Yeah, this orange, actually, we can paint that. That's a 2-cell orange, that's a 2-cell orange. This is a 2-cell orange going to one of those cells, and this is a 3-cell orange. Okay, good. We've found all the greys. We've found 5 blues. I'm still concerned that we might have an extra blue cell in one of these places, maybe, or there. Anyway, if we did that, we would have to have 5 digits that could add up to twice x. I'm calling this cell I'm in x. And that means that would have to be 8 or 9. Well, it can't be 9. It would be 8. And the 5 cells connecting to it would be 1, 2, 3, 4, 6, adding up to 16. And the only way you can form that into a pair and a triple is a 6-2 pair and a 1-3-4 pair. And the digits we would have left over for here are 5, 7, 9. And that does not make a successful region sum line. So this is not a 6-cell line. This is a 5-cell line. This is complete. This line is not complete. It's going to have a 4th digit in one of those 2 cells. Wow. I mean, this puzzle is brilliant, by the way. Absolutely bizarre and mind-boggling. And at some point, we're going to have to do numbers in the puzzle. We are miles from that. 24 minutes in, we've established the arrow. We've established one of the region sum lines and almost all of the other. Oh, this is going to be odd, because we need this region sum line to add up to an odd total. If it was 5, these would be a 1, 4 and a 2, 3 in some order. Oh, then this line would be okay. It would add up to 15 in 2 segments. One of them being 6, 9, one of them being 8, 7. So that could be 5. The only alternative is the other odd number that is higher than 5 and is not 9, and that's 7. Then this line would add up to 21. This line would add up to 24 and be made up of 2 sets of 12. That's equally possible. This puzzle is bonkers. That's just an official thing. I'm very concerned. I can't do anything else at the moment. I've established with my orange lines, I've got a 2-cell line here that's complete and a 2-cell here. This is the beginning of a 2-cell line. There's a 3-cell line connecting those. Who knows? Well, trouble is Dutch whisper digits are not very useful in that respect. Every single digit in a Dutch whisper universe has at least 2 other digits it can connect to. 4 can connect to 8 or 9. 5 can connect to 1 or 9, 6 can connect to 1 or 2, and they're the most constrained. And I mean, the Renban lines, I don't know, one of them's presumably 3 long. Oh no, we said this one might be 5 long, didn't we? It's nearly run out of opportunities to do that. I think it would have to be exactly this shape if it was 5 long. But, I mean, that's just a lack of information. That's not extra help. I'm going to have to think about these numbers. Right. This pair adds up to 9. Ah, where does this digit go in box 5? Oh, that's beautiful. It's not allowed to reappear in grey. Remember, our grey cells are a set of 1 to 9. This digit can't reappear in grey and it can't go in those cells. Its place in box 9 is there. That is 5 or 7. This is 2 or 4. Where does this digit go in box 5? Again, it can't go in grey, so it goes in one of these cells, and so does this one. So those two have to form a fair Dutch whisper partnership. And this one has to be high. It can't be 1, 2, 3, 4 or 5. It can't be 9. It is 6, 7 or 8. And this digit is 1, 2 or 3 to make up the sum to 9. And that 6, 7 or 8 appears on this orange, as does that 2 or 4. I mean, that's crazy straight away. Okay, no, I was going to say if that's a 5, then the other digit from 2 or 4 appears here, and that's true, but it might be a 7. I mean, that's interesting in itself. Maybe we think about what these are then. If that's 5, this pair adds up to 9. I mean, that's weird. That even on its own is a weird, just because that digit's the same as that and this pair adds up to 9. It's obvious, but it feels a bit spooky. I mean, I wanted to do something about the Dutch whispers or about... I haven't thought about red cells for a long time. Or pink ones. I don't know. I think I have to keep focusing on blooming box 5 and what's going on in it. And whatever is going on in it is weird. That digit and this one. No, which digits appear here? That digit and this one. So if that's a 6, this is 6 and 2. I presume this just works out then in that case. Then that's a 7. We have 7 here, 3 here, 6, 2 here. Yeah, these would be a 1, 8 and a 5, 4. That just sorts itself out eventually. Now, if that was 6, 2, does that give me any kind of constraint issue? This pair is those. Okay, so if that's 4, this is 8. Then this is 4, 8, and then these digits are 5 and 1. Yeah, they become the complements. Okay, I sort of grasp how this works now, but not what I can do with it. I'm really proud of finding these lines that I've drawn in. It's given me nothing else, but I'm proud of it. I mean, I do want to take this on and convert it into something useful, but I am struggling. I mean, I could observe that this digit has to go somewhere on an orange line, and it's not there, there, or there, but that's not very interesting, is it? I'm going to have to do something with lines. I mean, I've got a red either there or there. I've got a red sprouting out of here to go north. orange sprouting out of here to go north, blue sprouting out of here to go north. That's quite, oh, that's definitely 2 and that's 2. These are finished. This is going to be 2 either there or there. I mean, I'm tempted to try and talk about high digits and low digits in orange, but this can't, okay, this cannot be. If this digit was 5, or is it not 5? One of them feels like it's a stretch. I don't know why. Maybe I've done this thinking already. If that isn't 5, this isn't 4, so 5 and 4 will go on a pair here. Okay, what I'm now saying is 5 can't be on this orange line, because this would be a 5-1 pair. Oh, and you could never put 8. Oh, well, that's interesting. You could never put 8 in the box. So there must be a bunch of these digits. Anything that goes with 4, 6, or 8 can't go on these. So 5, 3, and 1 cannot go on this orange line. So there is a low digit on the orange line. Well, it's 2 or 4. We knew that. Okay, well, then I'm not learning any new knowledge at all. If that was 2, this couldn't be 2, 7 then. This digit goes in this, and this does 2. But if that was 2, this couldn't be 7, because that digit would be 7. 7 would then be colliding. So I don't think this digit can ever be 7. Because if that's 4, this is 7, but they're meant to appear on this Dutch whisper together. So this digit is never 7. That's taken me a long time to work out. It's been totally available the whole way. So 6 or 8, this is either, that's weird, is that right? This is either, no, I was going to say this is either a 4-8 pair or a 2-6 pair, but maybe it's a 2-8 pair, and that's 7 and 1. Okay, what happens if this is 3? Something bad happens. Then this is 6. This is 2 by the Dutch whisper relationship, and this is 7. No, nothing bad happens. You've got 3 and 7 there, and 1, 8, and 5, 4 here. That's fine. No, okay. I don't know. Now I'm really getting a bit. Well, it's easy to say I'm getting stuck. Obviously, I'm getting stuck. But mind you, this whole puzzle has been a case of gradually ungluing myself piece by piece. There's some aspect of the rules and their effects that is going to work for me here, and I don't know what it is. What is it? What is it? Right, is there some reason the Renbans have to join together? I just don't buy that. Why can't they all be separate little 2-cell bits and a 3-cell bit somewhere? No, it's got to be around here somewhere if we're going to do anything else. Have I missed a rule? No, I just haven't. Okay, let's think again. My goodness, this is frying my head. How do the lines help at all? Right, Dutch whispers. Dutch whispers. What are they doing? This one uses either 2 or 4 and 6 or 8. Okay, let's imagine it used 2 and 8. Then on one of the other Dutch whispers, there would be a 6 that would be tied to a 1. And there would be there would be a 4 that would be tied to a 9. Oh, and then the other digits are 3, 5, and 7. And the 3 can go with the 7 on the 4th line, but the 5 is going to have to go with the 1 or the 9. So the 5 would end up on the 3-cell line in that circumstance. That was me postulating a 2-8 pair. Maybe that's because that was the hardest pair. If this was a 4-8 pair, well, you've still got the issue with... Oh, no, you haven't now. Does 3 always have to go with 7 on one of these 4 Dutch whisper lines? Wherever the 6 is, it will... I don't know. I can't work this out. There is either a 2 or an 8 on this line. And that is going to constrain something. This line can't be 4, 6. It's made up of those 2 digits. So there is either a 2 or an 8 on it. So if there's a 2 on it, the 6 on a Dutch whisper line, which can't be on this one, must go with a 1. Yeah, if there's a 2 on this line, the 6 on a whisper line, let's say it was down here, must go with a 1. Then the 7 on a Dutch whisper line must go with a 3. Then you've got 4, 5, 8, and 9 left. Oh, hang on. I was saying if there's a 2 on this line, the 6 is on a different line. That might not be true. This might be 2 and 6. That is actually very likely. Oh, that's annoying. Right. I've only just had this thought, and it's quite a big thought. If that's a 5, this is a 4, and that 5 is going to have a definite 2-3 pair here. And that would be a 1-4 pair. So if that's a 5, this is a 4, that's a 5, there's a 4 on here then, with 8. So if that's a 5, that's a 4, that's an 8, that's a 1. And this 1-4 pair would be resolved as a 4 on top and a 1 below. Okay, things are quite constrained if it's a 5 in the circle. I don't know if that matters. These would be 4, 8 on the orange line. And then there'd be, I don't know, that doesn't impact the other orange lines very hard. Oh, hang on, baby. I've got something. Right. If this was a 5, this blue line would be 1, 2, 3, 4, 5. This blue line would be 6, 7, 8, 9. All of the cells in it would see this pair of orange digits, or this trio if orange went all the way to, oh no, not to there. Anyway, this pair would see all of 6, 7, 8, 9. They would have to be a 1, 5 pair. If that was 5, and this fails because both of those would be 5, and this would be a 1, 5 pair. That is insane, Staxis. That is insane. It is utterly brilliant, but it is insane. Right, I'm going to take you through that again. If this digit was a 5, that makes this one a 5. That makes this line a 1, 2, 3, 4, 5 blue line. That makes this one a 6, 7, 8, 9 blue line. I don't know where the 4th digit is, but it's in box 8 because of how the line works. Now these two digits see all of 6, 7, 8, 9, and to be an orange digit pair from 1, 2, 3, 4, 5, they have to be a 1, 5 pair, but we've just worked out 5 can't be in either of them. That is mad. That is absolutely insane scientist level. But it means these are 7s. Now 2 is going to be on this line. I mean, I don't know if I'm going to get anything else out of that. I now know 7 can't be on this line. That's totally uninteresting. This line, by the way, and now that's 7. This blue line adds up to 21. This one adds up to 24. It is going to use 2 pairs that add up to 12 and don't use a 7. Those 2 pairs are going to be 3, 4, 8, 3, 9 and 4, 8. So this line is going to be made up of 3, 4, 8, 9. These 2 cells won't be allowed to be 3, 4, 8, 9 or indeed 7. So these are made up from 1, 2, 5, 6. Actually, they can't use 2 either. So they are either 1, 5 or 1, 6. That's bizarre, but it's good. Now, 3, 4, 8, 9 will have gone on the blue line. These ones are a 2, 5 pair there because of that 2, and a 1, 6 pair resolving this digit as an 8. And we've got some traction. 1 there, 8 goes on this line. This is a 2, 8 line. I was trying to rule that out earlier. I shouldn't have because it's right. These digits are a 3, 6 and a 4, 5 pair. That is fantastic, by the way. Fantastic breakthrough. Absolutely bonkers. And this line is not complete, but it's going to be 3, 4, 8, 9. Now, on the orange, we've had a 2, 8 and 1 definitely in use here. We've got 3, 4, 7 and either 5 or 6 and 9 to place on 2 other lines. 3, 4, 7 and 9. Right. The 4 is going to have to touch only a 9. The 3 then, it could touch the 9 or a 7. Well, what's the 7 going to touch? 7 can only touch 3. So one of these lines will have 7 and 3 on it, and the other one will have... hang on. If this was a 1, 5 line, 6 wouldn't have anything it could touch on either of these lines. So that's a 1, 6 line. There we go. That's weird. That's true, though. These are made up of 3, 4, 5, 7, 9. And I think the 5 is going to have to attach to a 9, and so is the 4. So this is going to be a 3-cell line of 5, 9, 4. And this is going to be a 2-cell line of 3, 7. Yeah. 7 can only touch 3. 4 and 5 can only touch 9. That is right. This is a 4, 5, 9 line. So there's a 9 in between those, and it's now big. We know it's there. There we go. That's another finished line, incredibly. This one down here is a 3, 7 line. But I don't know where the other cell is. But one of those is a 3. So this line is, this bit of this line is not the 3-9 pair. That's the 4-8 pair. This is in the 3-9 pair with another digit. Wow, the 3-7 was confined to this box. That's mad again. Yet again, utter madness. Look at this 1-6 pair now. The remaining digits in this column are 3, 4, and 5. That's actually impacting on the Renban. Oh, hang on. This digit's 6. That's 1. This is not the 6-3 pair. This is not the 4-5 pair. There's a 3 here. This digit is 9. And now it's got to hit a 3, and that's got to be here in blue. Bingo. Bingo, stingo. Unbelievable. Finished another line. And indeed a whole set. That is all the blue set done. Ah, look, the orange second digit is up here and can't be a 3. So the orange second digit is a 7. The first digit is a 3. Oh, I'm seeing more. I'm seeing a 4-5 pair that sorts out that as a 2. That's a 5. That's 4. That's 5. 4, 5, 8, 2... 6, 1, all the orange, oh no, not all the orange is done because I haven't placed the 7, almost all the orange is done. I mean, I'm getting Sudoku to do now. You don't know how exciting I find that. This is a 3-9 pair. This is because of this 4-5-8 triple that I found. This is a 2-7-8 triple. This can't be 8. Right. Now maybe we can start looking at the pinks and the reds. Although, frankly, I prefer Sudoku. I've had a whale of a time doing a bit of Sudoku. There's a 2 in one of those cells. Right, these pink lines. Yeah, let's think about them, because I thought they were 3 2-cell lines and 1 3-cell line, but I have never ruled out a 5-cell line. I think it makes quite a big difference because you could get quite a spread of digits on a 5-cell line. I can't draw it, sorry. It's beyond me now. There we go. That's the possible 5-cell line. Maybe we could rule that out. If that was a 5-cell line, it would have 4, 5 on it. It wouldn't be allowed a 3 on it. These would have to be 6, 7, 8, and they can't be because of that 4, 8 pair. Right. There is no 5-cell line. It's not possible. Oh, hang on. This could be a 5-cell line. Oh, stop it, pink. Oh, I'm getting annoyed now. Silly pink. Oh, there's a 4 in one of those cells. There's Sudoku. Maybe I should be ruling out 2-cell lines, because that would have to be a 4-5 line if it was only 2 cells. And this one would be under enormous pressure. That digit would have to be an 8, tying to a 9, at least here. I don't know, I'm not loving the fact that one of these, at least one of these pink lines is definitely more than 2 cells, because it just has to be. Okay, but this is what to think about now. So, oh, well, here's an interesting deal. Where does 3 go on a pink line? I don't know. If there were, I don't know. Because this one can always extend. Oh, it's so confusing. It's got to be pink lines in X, though. I can't, there's nothing I can do with reds. I don't think there's anything I can do with reds. Oh, that's not an 8. This is just Sudoku. And there's a 3 down here somewhere, so not in that circle. Or a 9. What about this one? This can't be 5. Yeah, and there's got to be an even digit in one of those two for the reds. No, I mean, there's nothing. There's not. I've got to do pinks. I've got to do pinks, and I've got to figure them out. Right. This red has to extend up. Does that... Did I rule out this being a 5? I did rule out this being a 5-cell line because you just couldn't make it up. It would use 4, 5, and then you'd have to either use 3 or 8 here, and you couldn't. So this is not a 5-cell line down here. Can I rule out this being a 5-cell line? That would leave 2 2s down here, and this one would be 4, 5, and then there's no such thing as a 5-cell line because it would need a 5. So there is no 5-cell pink line in this puzzle. There are 3 2s and a 3. This one could only be the 3 if it was 4, 5, 6. 6 could be there or there. And it can't join to that and be a 2-cell line. It can't even be a 4, 2, 3 line because that would just leave 1 hanging, unable to go on a line. So this pink line includes those 2 cells, and that's 4 and 5 gone. This digit is an 8. 8 must attach to 9 on a pink line. This was something I was hinting at earlier, because otherwise if 9 is not on this line, then it can't go on a separate pink line because 8 couldn't go on it. So this must attach to a 9. It's not one of these 9s. And also we've now had 4 and 5 on a line. I admit they could connect to 6, but they can't, in fact, because that would leave 9, 8, 7 as one group and 1, 2, 3 as another group, and we've got 3 lines to fill. So 4, 5, that is a complete line. It can't connect to 6. We're done. 8 is going to connect to, and therefore the digits above 4 and 5 in the sequence of digits are 6, 7, 8, and 9. That's going to form 2 lines. A 6, 7 line and an 8, 9 line. There is one possibility that I have left out of account, and that is that this 4, 5 line could connect with a 3, and that 3 could be here. So I'm bringing that back in. However, the digits above, these can't connect with a 6, because that would be a 3-cell line and leave 2 3-cell lines, and we've got 3 lines to do. So 6, 7, 8, and 9 connect together as 2 pairs. So this 8 connects with a 9 in one of those cells. Of these 2 lines, one of them uses 6, 7 only. It's not this one because the 7 in this box is promised to the 3. So this is the 6, 7 line of 2 cells. And then this line has 1 and 2 on it and maybe 3. Well, it doesn't because the 3 is promised to the 7. They're an engaged couple in this box. That 4, 5 is going to have to connect to a 3, and that 3 is going to be here. And we've done it. We've done it. That line is complete. Oh, well, we don't know where the 6 and the... Oh, that 7 is looking at this cell. So that's a 6. It needs to connect to a 7 somewhere in this box that is pink. Wow. I mean, this is mad. And there's a 9 in one of those cells. Okay, but that has done quite a lot of stuff, I imagine. We got that 3, so that sorts out 6, 3. Central box is finished. We've got 1, 6, 7 to go in this row. 3 is over here somewhere. That 1, 2, 4, 8. We've got 5, 9, 7, 6 in this box. This digit is 5 or 6 on the red line. That's not as helpful as it could be. This 4, 5 pair are not done. This 3, 9's not done. We do need a 3 somewhere up here. Even digit here. This can't be 3. goodness, there's still a lot to go in this puzzle. It's so fun when you get on, oh look, that 1 is looking at that cell. Well, that's quite good. 2 there, 1 there, 2 here as well, 7 in this cell. These are 3, 5, 9. That digit now can't be 5 or 1. We've found an odd digit on a parity line. That's a 7. We can't put another 7 in a red cell. So this one is 1 or 9. Have I got a way of knowing? If I knew that wasn't a 1, I would. Right, and there's an even digit here. No, that's no good. 3, 1, 9, 7. This sees 2, 5, 8 in the column, so it's 4 or 6. Okay, this box, 2, 4, 5, 9, 3. It's not that useful, is it? Gosh, you get something done, you think it's going to yield everything. Oh, there was a 9 in one of those cells, so that's not 9. So we've found 9 in this box. That's a bit strange. And that places 7 in the box. And this digit is 5 or 6. That 7 is our orange digit that was betrothed to the 3 and is now married. Hurrah, ring the bells. This 5 must connect to that digit, and that's a perfectly acceptable red pair of 5, 6. Well, I mean, I don't know which way round they go, and I was bothered by that, but actually, no, I'm not bothered by that. I've eliminated 5 and 6 from all red cells. This one also sees 2, 1, 8, and 7, so that's 3, 4, or 9. This one sees 2, 9, 7, 1. It can't be 5 or 6. That one is 3, 4, or 8. It's basically treating the red cells now as an extra region that I'm hoping is going to do something. This digit is naked, sees 3, 6, 2, 5 in the row, 1, 7, 9 in the column, 4 in the box, that's an 8. That sorts out 4, 8. This is now a 3. That's great news. I can do 5 and 6 in the column as well. 6, 3, 5, 2, 4, 9, 8, 1, 6, 7. That's a naked 6. And I'm left with a 1, 7 pair in the box. This is 7 or 9. Oh no, it can't be 9 because of the requirements of pink to touch a 9. That's lovely. Right. That is a naked 4. This one isn't allowed to be 3 in red, so it's a 9. That's made this one a 1. Now the digits I have in red so far are 5, 6, 7, 1, 9, 3. I have 2, 4, and 8 to find in red, and one of them has to link 1 and 7 here. I mean, I'm leaving that. That 1 is sorting out 7 and 1. This is, oh, I can do 6 and 7 here now. This is 3 and 8, isn't it? Yeah. This is 4 and 9, and I don't know the order. That's concerning. Right, this needs a 2, 9 pair to complete the column. This is 1 and 8, I can do those. That 3 is sorting out 3, 9, which sorts out 2, 9. Oh, I can colour that 9 in pink. This digit can't be the 7 that pink is going to attach to here. 6, 3, 8, 7. Neither of these can be the 3 in the bottom row, so we've found that. Oh, in fact, that can't be 9, so they're all done. That sorts out 4, 9 there. In this column, there is 1, 2, 5 needed. There's the 5. There's the 1. There's the 2. That sorts out 8, 2. 4, 5, 6 triple in this row. I expect something is resolving that at the moment. Can't see it. 8 in this box goes here. This is 4 or 6. Okay, in the column we need 1 and 7. That 7 is going pink and completing pink. Right, in this final column we've got a 2 and a 4. I can do them. Not only that, they're going to sort out my 4, 5 pair, which sorts out my 4, 5 pair, which sorts out my 4-6 pair. And just before I finish this off, let's find our last red cells. What did we need? 5, 6, 7, 1, 9, 3. 2, 4, and 8. That one can link to 4. Oh, this one is linked by an 8. So there's 8 found. This one now has to link to a 4, not a 2, I think. And then this one must link to a 2, and there it is. And I think I've remembered to do all my colouring. And I've assembled assembly required in just over an hour, and I'm very proud of myself. I'm very impressed by you, Staxis. That is a phenomenal puzzle. Look at that. Not many people have done that in nearly a month. And that's because it's rock hard. I mean, there were stages near the beginning there where it just felt there was no possibility of another move being made. And yet they were all perfectly logical. That business about 7 or 5. Oh, yeah, no, it was that was a really hard step, working out that this being 6, 7, 8, 9 would make that 1, 5, which had become impossible. That step. This puzzle is so hard, it's obviously linear. That step was required, and it is unquestionably one of the hardest steps in a puzzle I've seen. Fantastic stuff. Thank you for watching. Really enjoyable, tough puzzle. And I'm pleased I've got through it. I want to see you again tomorrow. Come back for more. Maybe it'll be easier. I hope so. Bye for now.